Right, okay, so I am Tim Perry, Pim Terry on Twitter. I work for a company called Softwire, and I want to talk about automated builds, particularly ways you can spot, you can smell that they're going wrong, signs that we've got issues, and things we can do to kind of fix that, to bring that back in check. Nothing ever works. There we go. Context to start with. I work for a company called Softwire. We have offices in London and Bristol and Bucharest, and we are recruiting there if you're ever over there. But we spend a lot of time helping fix people's builds. We build products for other people. We work with other companies' teams. We do consultancy, all this kind of stuff. We see a lot of companies, and we see a lot of the different ways that stuff breaks for them and the different levels of success they get with trying to recover from that, trying to come back from that pain and put their developers in a place where they can quickly and effectively build stuff and move forwards. But yes, as I say, I should note that we are hiring if you're ever in London, Bristol or Bucharest, and we are available to hire wherever you are. Do come talk to me later if you're interested in that kind of thing. So when I'm talking about builds here, specifically, I'm talking about the tools and processes you're using from getting from the point where you write some code to the point where you actually deliver a useful thing to a customer who hopefully likes it and throws their money at you. This is something that we kind of ignore a lot of the time. It's something that a lot of people don't take particularly seriously, and it's sort of a hassle, a distraction from getting anything done. And it's certainly not the fundamental of your business necessarily, but it is the thing that lets you do whatever your business does. If you want to put code into production, that goes down some kind of pipeline that compiles it, linting tools, does some testing to make sure it actually works, and some releasing to get it into production. And if that doesn't work, and that doesn't work quickly, you slow yourself down. We see teams a lot of the time where they sink huge amounts of time into fighting the processes they've set up, where they've got setups that are designed primarily, really, to get in the way and stop them doing anything wrong, rather than to support them in doing stuff well. So I want to look at 3 specific ways builds can go wrong here, and use these to find these improvements and this value so that we can actually deliver some value better, so that we can build stuff better, build it faster, and kind of a bit more enjoyably along the way, as much as possible. I should note, before we dig in, this is gardening, not architecture. I am absolutely not suggesting that you try and build a glorious monument to your brilliance as your build system. You don't need a really fancy, clever thing, and if you try, it will probably go horribly wrong. Rewriting your build tools in Haskell is probably a terrible mistake, no matter how shiny and exciting that might be. And this is much more of an organic process. You want to try and spot actual pain your team are feeling in practice, actual things that are slowing you down, causing you issues, and find actual concrete improvements to these. Find specific things that are going to make them better, weeding and pruning, and organically kind of growing this as you go, rather than trying to design a big shiny thing up front. We're going to start with merging. We see a tragic number of teams who sink a huge amount of time, really, into merge conflicts, into extraneous process over the top of this, and into a lot of hassle all around this. Teams where you accept that you're going to have a person spending a day a week resolving conflicts and bringing stuff together. Occasionally, teams where they do this quite explicitly, and teams split up into a few subgroups, build a bunch of stuff, and they merge it back together 3 months later. And they sink a whole bunch of time into merging it back together, but they also end up with this massive pain. You get bugs coming in, nobody really enjoys this, there's very poor communication that comes from this. This causes lots of problems. And having merge conflicts, and constant merge conflicts particularly, coming in, doesn't just waste your time. You're also making it near impossible for you to do any refactoring. If you're expecting there to be a major conflict, you can't make sweeping changes, because it's going to be an enormous conflict that destroys everything. You need to be able to confidently push code and easily combine it with the rest of your team to be able to do these refactorings, to be able to develop software easily and to be able to develop software well. So, an interesting point here, I think, is that an enormous number of these are avoidable. Nearly all of them, I'm going to confidently say. I think you can see this most easily if you break it out into kind of the different types of conflicts we see in practice. So you get sort of basic syntactic conflicts. I've changed one line, you've changed another line, and our changes are independent, but they happen to be in the same place, so version control isn't really sure how to combine them. Let's say we've both added a field to a class, and it happens to be in the same place, but when these get merged together, it doesn't really matter which way round those end up. They're probably independent changes. And quite a lot of conflicts are in that kind of place. Notably, these are easier to deal with if you find them sooner. If you've got one or two of these, that's fine, and if you've got hundreds of interlinked ones of these, that gets much, much worse. These also totally disappear if you make the changes in sequence instead of in parallel. If, rather than having two people adding a field to a class, for example, at the same time, one person adds a field and then the other person checks it out and adds a field, not only will you not spend any time resolving conflicts or fighting it, you won't even notice there was an issue in the first place. Completely disappears. We also get semantic conflicts. So you can have quite simple semantic conflicts where we've changed different sections of code, and those areas of code have some semantic relationship. They affect each other directly, but they're not necessarily syntactic conflicts. An easy example is if you change a method to return centimeters instead of meters. Say you change the unit that comes back, and I add some new code that's calling this method. When we merge these together and my code unexpectedly gets centimeters instead of meters, it's probably not going to do what I expected it to do. And I'm going to get some weird behavior there because of the semantic conflict we've got going on. But again, these are much easier to solve if you can find them earlier, and simple conflicts like this totally disappear if you make the changes in sequence. If I was writing code and the method already returns centimeters, I immediately see that and I write it with respect to that. Like, that is the world I'm already assuming at the beginning, that is the world I'm building on, and I don't need to even know that there was a conflict, even though there was an issue at all. We do then also get actual kind of fundamental semantic conflicts. You want to change a thing and I want to change a thing in mutually exclusive ways. We've got something that we're not going to be able to combine here, and at that point we have to make some kind of compromise. There needs to be some sort of discussion. And if you make these in sequence, you're still going to get into some trouble. So if I want to refactor a class and remove a bunch of methods because they no longer work with my design, and you want to write a bunch of code that depends on these methods existing because that's really important, like whatever happens, we're going to have some trouble trying to both do what we want here, and we need to come up with a new solution. Again, these are easier if you can find them earlier, though. So anything where we can push this kind of stuff earlier and move to be doing more sequential development and keeping less stuff in parallel gets easier. Fundamentally, all of this is being driven really by developers isolating their changes from one another. Every time you keep code on a branch for longer, anytime you keep code local and you don't push it, you're hiding that code from the rest of your team. Those conflicts would disappear if you were sharing your changes earlier, and instead you're keeping them isolated and keeping them secret. And there are certainly advantages to this in lots of cases. You probably want to keep your local changes isolated from production, for example, because some of your local changes won't work. But this isolation does come with a cost, and particularly between the different developers on your team. And trying to reduce this isolation where we can has a lot of value. So sharing early is really the name of the game here. What we found for teams that were really struggling with this is that trying to push to a point where you share your code with the rest of the team every time it works, and trying to work effectively in a way so that you can bring that down to a couple of times a day, really quickly gets rid of this completely. You can see almost overnight teams going from spending a day a week dealing with merge conflicts and generally worrying about merging and it being a bit of a hassle, to that being a conflict every 6 months or so. These issues really do just disappear surprisingly easily. So some kind of specific examples for this. If you've got some tests, say, for example, if you're about to refactor some code, you're going to write a passing test for it first. That would be a nice, sensible thing to do. Once you've written a passing test, your code base is in a state where it doesn't break anything if you share it with everybody else, right? All the tests pass, you haven't changed the functionality, everything works. You can immediately commit and push that test. All it does is improve everybody's code base on the team, and it means that that test is never going to conflict. If somebody now refactors the tests, they're also going to refactor your tests along the way. If somebody renames the methods and the APIs you're using and things, automated tools will even rename the code you've just pushed for you without anybody noticing. With zero extra effort, you get no more conflicts in this test. Even failing tests, you can get a reasonable amount of benefit out of doing this. You can mark tests as ignored and then push those. There's definitely less benefit to it there. It requires a certain amount of rigor to make sure you actually clean up after yourself. But quite quickly, you can get very easy benefits out of this in testing code. In the business side as well, if you're adding a new field, a new method to your models, it's probably not immediately changing the behavior of your code. Typically, adding a field is not going to break anything. Certainly, adding your new interesting methods, the various parts of the story that you're completing, individually can be committed and shared earlier. And as soon as you do that, you stop there being any conflicts. You communicate better with the rest of your team so that everybody knows what's going on, so that everybody can see conflicts earlier. And these issues come up earlier when they're easy to deal with, and the problem goes away. And generally, we're just pushing here for trying to share as much as possible everything. Everything where it doesn't cause any impact, so everything where the tests still pass, where the code is still essentially ready to go into production, where you're happy with the state of it as working, sharing that with the rest of your team. This is not just quite good for merge conflicts, this is also just a very good way to work. Rather than doing your stories in a huge, enormous chunk of work, breaking them down into a small series of incremental pieces where it works repeatedly all the time is a good idea. In and of itself, you end up not kind of yak shaving, not following down some complicated, crazy path and ending up with a huge, massive thing, and instead you think through and you plan and you slightly more rigorously and more carefully can actually manage how you develop. Some bits of code can get more difficult for this. So if you want to rewrite your whole user page, for example, in your web application, this is plausibly quite a big chunk of work. You've got a whole bunch of redesign, you're moving things around, and it's difficult to change that whole page incrementally. And this is where feature flags really come in. Essentially, you move to a position where you branch in code rather than branching through version control. So fundamentally, you add a new configuration property for your feature, let's say new user page. You default it to off, so it's off for everybody else. And then in the user controller, you say if new user page is on, show the half-built new user page, otherwise show the current existing new user page. And you can share all the code with everybody all the time immediately, while still isolating the functionality. Nobody else is going to see that old user page, that new user page. And this allows you to share stuff earlier and to more frequently combine things with the rest of your team. Notably, this should be your last resort. It's easy, if you're not careful, to add quite a bit of complexity through your code base if you start riddling it with if statements everywhere. You have to clean up after yourself. So trying instead to share things in an incremental manner like we've talked about a minute ago would be better where possible. Lots of businesses do take this quite a lot further, though, because you can turn it into a feature in and of itself. So if you look at people like GitHub, Lanyard, Twilio, they use feature flags to progressively roll out features to turn things on for beta users only, for example, or do A/B testing between users, or this kind of thing. All of a sudden you gain quite fine-grained control of exactly which features are enabled where if you go a long way down this road. But even if you don't, there's quite a lot of benefit to making it easier to share this code. Branching is really, really good in modern version control tools, and that is really, really great. And it's a powerful tool that can do a lot of really neat stuff, and I absolutely do not want to suggest that you should never be branching. It feels like a lot of the time, though, we branch because that's what you do. And you don't really have a specific reason why you want to branch stuff. You put new features on a branch and then you merge them back in immediately. And if you don't have a concrete benefit that you're getting from branching, you are paying a concrete cost. Isolation comes with cost. And branching instead, when you have an actual good reason for it, will give you much more of the actual benefits with less of the cost. So if you're developing experimental features, for example, keeping them on a branch is very sensible. If you're working in an open source community where you can't just merge everybody's code in all the time without really worrying about it too much, you need to have some sort of branching model. If you're trying to track releases and hotfixes and this kind of thing, branches work really great for that sort of stuff. There's lots of reasons why you do want to use this, but do it intentionally. Have a reason, a benefit you're going to get out of branching, because you're going to end up paying the cost. So, first of these spells, we start off in a position where we're losing time, where we're fighting with merge conflicts, with trying to communicate with the rest of our team effectively, and you move towards a situation where you build many much smaller merges, much smaller pushes, combining your code with the rest of the team more frequently. And by doing so, they become easier. Your merges get smaller, so it becomes easier to make them. Your merges get easier, so it becomes easier to make them smaller, so it becomes easier to make them easier, and so on. So we made a whole bunch of changes. You want to share them with the rest of the team. It's quite easy to get in a place where doing so is scary, because you have no idea what the build is going to do. You simply don't know whether the code you've written on your machine is going to pass. That very quickly puts you in a position where you don't want to push code. And as we've just looked at, sharing code with the rest of your team is better. The more you can do that, the better. So you really don't want a situation where your tools are pushing you against doing that. And it becomes distracting as well. If every time you make a change and push it, you don't really know what's going to happen, you have to keep one eye on the build system and work out what's going on. And even if you don't do that, if you suddenly get an announcement 2 hours later that all the changes you made were shit and you have to go back to square one, that's going to take you completely out of your flow and you're going to lose a bunch of time. And it's not going to be very fun. Particularly if you're hearing this kind of thing. At this point, you've written a bunch of code on your machine, and despite the fact you've got the whole thing there, you have no idea what it's going to do on the remote build system. Let's just push it up there and see whether the build passes remotely, because we can't check locally. Here, even worse, we've pushed it, we've run it remotely, and we still don't know what it's going to do remotely. As soon as you get into this kind of position, you're getting a smell that something is wrong in your build system, and it is making your team worse. You're building worse software, and you're building it more slowly if you're fighting with these kind of problems. Fundamentally, doing this kind of stuff well depends on confidence. If you can write code and really quickly get a good idea that it's going to work, then you can build code faster. You can focus on what you're actually doing rather than getting distracted by these things. You make fewer errors, and you get this tighter feedback loop. If you think about the last time you made a syntax error, like syntax errors, you get immediate feedback, essentially, in any tools we use. And because of that, they haven't really become a problem. You look back to punch card times where syntax errors, you sent the thing in and then you got something back 2 weeks later saying, oh, sorry, this was wrong. You have that hugely longer feedback loop, and you make much more mistakes. You end up fighting with these errors, and generally, both for syntax errors and all kinds of checks for your build, the tighter you can get that feedback loop, the fewer of these errors you're going to make, the quicker and easier you're going to be able to build software. And once you can get that confidence, you can focus on the actual development work, focus on quickly understanding what you're building it well, and building more. There's 4 main areas that I see really driving this. You need your build to be accurate, so when the code works, the build passes. You need your build to be thorough, so when the build passes, the code does actually work. It doesn't pass even if it's broken. The build needs to be fast, so that you can get this quick feedback that's powering all of this. And we need it to be simple so that we actually run it. Accuracy. Fundamentally, it's very annoying. Like, when your build isn't accurate, that's really the driving force behind this. If you can't trust the build, if it fails, even though your code works, it becomes very frustrating. People stop wanting to use the build, and it really becomes a problem you fight, rather than a tool you've built that's supporting you and supposed to be helping your team. There's a lot of different things you can try to do to improve this, but by and large, external dependencies are the number one thing that really breaks accuracy here. Certainly in unit tests, getting rid of every external dependency you possibly can any external services, preferably dependencies on time zones, this kind of thing. Everything you can get rid of here makes these tests more reliable, more accurate, and gets rid of this frustration and lets you go faster. Identical environments also help with this similarly, and we're starting to get a lot of interesting DevOps tools that allow you to do that kind of stuff. So Docker and Vagrant particularly give you a lot of automation so that if you've got different development environments and a remote build server, you can have the same kind of VM config that is exactly identical on the two, so that you can get that confidence locally with exactly the same build environment. And having absolutely no tolerance for when this starts going wrong. And it does start going wrong at some point on every team. Some teams where this starts going really wrong, though, they rush past it. The build starts breaking, it's a bit broken, it's a mess, but we've got this release to do, so just turn all the tests off, turn the build off, move on, we don't need testing anymore. And even if you don't do that and you allow these occasional failures, it becomes very poisonous. You lose any trust in your build. You no longer have this certainty that code you're writing is actually usefully being checked before it gets into production. And you have to chase these down disproportionately to actually ensure that you keep this accuracy. If you end up with a build where half your tests sometimes fail, people just stop looking at the failure messages on the build, because that always kind of happens. And the PHP project particularly had an enormous security issue that came through entirely because they had random errors occasionally, so they didn't notice when a bunch of catastrophic hashing stuff that was really important was totally broken. Once you have these errors coming in, it becomes really easy to ignore them and really, really easy to end up deploying broken code and end up fighting your build system. So, thoroughness. How do we make sure these tests, this build, actually checks whether our code works? Coverage is an interesting one. It is easy to set arbitrary coverage targets. It's probably not a good idea. Coverage is very useful information. The overall trends in coverage, for example, are important facts. If your coverage is going up, you are probably doing sensible things. If your coverage is going down, you probably have a problem. Knowing which areas are well covered is very useful information, but line coverage doesn't necessarily mean you're testing things well, and once you start putting in arbitrary metrics like that, it becomes easy for people to get distracted and start gaming them and so on. And focusing instead on the overall message that coverage is giving you and making that information as visible as possible gives you much more of the benefit without worrying so much about the specific targets. If you're in a particular problem, setting goals is great. If you've got very low coverage and you can say, okay, we're going to shoot for 20% by a month from now and start building up like that, sure. But coverage is not the be-all and end-all, and I would not set arbitrary targets you're going to just stick at forever. You want to try and really ensure instead that you actually look and think about whether things need covering. Specifically, you want to ensure that any risk, anything that might actually go wrong, is covered somewhere. Lots of teams write unit tests for everything. They're very good about this sort of thing. And then something can't really be unit tested, so they just don't really test it. And at that point, you've got an enormous problem. You've left yourself in a gap with something simply because it's difficult to test. And often the bits that are difficult to test are also the bits that are more likely to fail. They're the complicated, fiddly things. If you can't test it at a unit test, really prioritize getting it well tested at another level. If you have to write a bunch of slightly fiddly integration tests to make that work, fine. But ensure that it actually gets tested somewhere. And finally, try and test what actually might fail. One of the things that makes this kind of stuff difficult and that gets resistance against seriously committing to testing is when teams start over-testing. If you start testing every single getter and setter, for example, you're not really getting any useful information. It is very unlikely that your getters and setters are going to fail. You're not going to make changes that break this kind of stuff. And instead, you can move your tests up a level. Test the chunk of code, including the getters and setters, which actually is slightly more complicated and might fail. Try and move your tests so that they're covering a size of code that is just complicated enough to fail. The simpler the code that you're testing is, the more useful the results you'll get. But if it's not complicated enough to fail, then you're wasting time, and extra tests come with maintenance cost and hassle, and you have to write them. Speed, the third of these four. We want to get quick feedback. The whole drive behind this is we need to have confidence, and confidence is much easier if you can immediately find out whether it works or it doesn't. If you get into a situation where you run the build and it runs for 4 hours and does a whole bunch of system tests and comes back and tells you that every single one failed, all of a sudden you waste huge amounts of time. You have to come back 4 hours later to the changes you were making 4 hours ago and try and work out what you were doing, and you have to drop whatever you were in the middle of doing, and so on and so on. That would have been really useful information to have 3 hours and 55 minutes ago. If you can make that feedback quicker, you can make life much easier. And there's a lot of different things you can do with this. Smoke tests particularly we found very effective. So if you mark your integration or system tests, just a couple of them, as smoke with tags or categorization, which almost every testing library will do, you can have a very small suite of, say, 5 representative tests, just a few sprinkled for some interesting, important pages on your application. You can set this up as a first step in your build process so that you quickly do a check of the whole site and then you thoroughly check the whole thing. And immediately, just by adding these little tags, which takes very little time, you get that quicker feedback. The first step, as soon as it passes, you know, yeah, my code probably works. I haven't broken the whole application. And you get, yes, quicker feedback. You can also then run these locally quite easily, and this allows you to put yourself in a position where people will actually use the Selenium suite. If you've got a Selenium suite that takes 4 hours, your team is probably not running it locally. But if you've got a very small smoke test version that takes 2 minutes, it's much easier to convince people to actually commit to using this and actually get the benefit out of it if you can get a representative set of tests there. And for unit tests, this becomes an even bigger thing. Certainly, I've been really pushing for trying to get them to the level where they're watchable now, where you can make a bunch of changes, kick off the tests, look at them and be like, yeah, cool, that works, great, nice, excellent, done. You can sit there for maybe 10 seconds, watch the stream of green go past without getting completely bored, and very quickly get a basic level of confidence that your stuff works. It allows you to move faster when you've got that quick feedback. It powers faster, better development. And finally, simplicity. What you're really trying to do is encourage your team and yourself to be actually using these tools all the time, to be powering your development forwards. As soon as it takes more than one click to do it, I'm going to get bored of clicking on things. I'm going to forget some of them. I'm going to decide that only these ones are important, so I'll only run these ones, and these ones will never fail. And inevitably, those will be the ones that do fail. It's typically also very easy to get down to one click to run all your test suites. You're probably running them from the command line somewhere anyway. Write a little script that runs a series of them. If you can get to the point where it's very, very easy to run the test suites, people will do. Similarly, if you can get rid of any setup, people are very bad at doing setup, both actually getting around to doing it, but also following the process of doing it. It's easy to go wrong and have one developer's machine slightly different from another, and then the tests pass in one place and not another place, and then nobody believes in the tests anymore. And all this stuff gets much more painful. Even worse than that, if you've got a whole bunch of setup for tests on one machine and then you change how your tests work and you have to do some other setup, you have to start thinking about migration patterns between a new developer setting up this test suite and an old developer who had the previous set, and you end up with these machines diverging and it gets worse and worse. If you can get tests that instead do their own setup, so starting up in-memory databases within the test, for example, starting up external test stubs within the test, having their own web servers bundled, this kind of thing, you can make it much, much easier for people to set up and make it much more reliable when it actually works. And finally, chasing easy debugging here. If it's not easy to debug why the system tests don't work locally, for example, if I can't run the individual system test that's failing on its own, then I'm not going to. If I don't even have a smoke test option and I have to wait 4 hours, I think you'll find a lot of the time people will just make the change they think fixes it and push it and see what happens. And you end up waiting hours and then it's still broken in hours and it gets worse and worse and worse. If you can make it easy to debug the tests, people will debug the tests. And you end up with better, more reliable tests. Chasing people's ability to have that zero tolerance, their ability to chase issues, to actually fix things, to hunt down spurious failures, will make it much, much easier for your tests to stay stable. So we start in a position where pushing is scary, where we avoid pushing, where our tools are encouraging us not to share our code, and you move instead to these accurate, thorough tests that give us quick feedback and let you get that confidence so that you can develop faster. Third smell then, releasing rarely. We see, yes, customers all the time where releasing is a big deal, where you're going to have a launch party, you're going to do it every few months, you're going to have VPs coming in and shaking everybody's hand. We're so proud you put some code into production. That is great. Well done. This is a problem. Releasing is the point where you actually do something useful. Up until that point, you've got code on your machine, and your customers do not care if you have code on your machine that solves their problem. They really want code in their hands that solves their problem. Unreleased code does absolutely nothing for your customers, and releasing is the point where you actually get something useful done. You add value in whatever way. You make your customers happy, they pay you money, whatever. All of this comes through you actually releasing something into the world. Critically, releasing something sooner adds more value. Not only do your customers start paying you sooner, and hopefully in the long run more, which is great, everybody loves that, also you get much more information. You find out if the feature you just wrote works. And if you find that out the day after you wrote it, it's much easier to deal with the feedback you get than if you find it out 6 months later. You also get much more information about what you should be building next. You can see from how people are using the features, from people's opinions now that you've solved this one issue, what your priorities are for the next tasks. And you generally get quicker feedback the sooner you can put stuff into production, in addition to more people paying you more money. Facebook, for example, release twice a day. Facebook are quite big, shall we say. They're obviously incredibly high profile. When Facebook goes down, it is international news. Who here releases at least twice a day? One person at the back. Nice. For the rest of you, do you think your code base is harder to release than the entirety of Facebook? They're in quite a complicated place. I mean, is your code base that much more dangerous to release than the entirety of Facebook? It's very complicated. It does a lot of things. Facebook are doing this twice a day. They're quite interested in trying to do it more. And they are big and very high profile, and it's entirely worth it for them. GitHub do it hundreds of times a week and actually write lots and lots of very interesting blog posts that I'd highly recommend taking a look at, talking about the specific power and benefits they get from getting this quicker feedback, from finding out what their users want, from finding out whether their code works, getting all this stuff quicker. And people like Netflix take it down to hundreds of times a day, at which point it's just a bit silly. But you're getting stuff into production very, very quickly. You're getting that really tight feedback, and you're getting lots of very small, very low-risk releases. Each one is only a very tiny change, and the more you can shrink those down, the more you take away the pain. So, okay, the big, fancy industry leaders are all doing this. Why is everybody else not? Why is everybody except one person in this room not doing that? Primarily, I think this comes down to it being risky. So releasing something is scary, it might break, and it being hard. It takes some time and some effort, and so we don't want to do that. So let's make it less risky. If we try and chase consistent environments, we can take away a lot of the risk. If staging is exactly the same as production, so you're running on the same servers, you've got the same software, the same database, the same data, so I'd highly recommend setting up at least nightly copies, replication back from production into staging, this kind of thing. If you can make these environments as close as possible. You can get really high level of confidence that having deployed it to staging, used it on staging, you can even get beta users to use staging environments, this kind of thing. You can get into a position where you can be really pretty sure that stuff probably works and that your releases are going to be safe, taking away the risk. You can automate the hell out of everything. This is the automation track. I'd highly recommend the rest of the talks. The more you can automate stuff, the better this gets, the less risk you have when you don't have people doing it. Deployment particularly is something people are terrible at. It's lots of fairly boring, repetitive tasks. If you've got a big manual deployment process, you really don't want to do that. You're bad at focusing on that. Computers are really good at boring, repetitive tasks. Give it all to the computers. Not only does it save you a bunch of time, it also gets rid of the risk. They're going to do the same thing every time. And it also lets you do interesting things like test your deployment processes, which is meaningless, really, to do with a manual deployment process, but very neat if you can get that set up with an automated deployment process. You can get really high confidence that it works. And measuring everything. One of the really high-profile bits around these companies here is that they talk constantly about all the metrics they're tracking. And once you start tracking these metrics, it becomes really easy to get the risk out of here. If you've got a graph that tells you that after your release, the same number of people are paying you the same amount of money as they were before your release, you probably haven't screwed up terribly. If your errors are about the same, if you're getting the same number of new user signups, whatever your important metrics are for your business, you can track these and you can get a pretty good idea that whatever has happened with your release, it's probably fine if these metrics continue doing what you think they should be doing. And similarly, when a release goes wrong, you get really quick, informative feedback about what's broken, why, and you don't start getting bug reports 2 days later from the one user who cares enough to start actually filing things for this. And then making it easy. Again, automate everything. The people are bad at this stuff, computers are good at this, delegate it all to the computers, and then you don't have to do any work. Try and get it down to 1 click or less, preferably. If you've got more than 1 click, it starts to feel like effort. Once you can get it so it is simply a decision of, are we in a position where we can deploy? Have we got something useful to give? Yes, cool, click, done. It becomes really easy to get people to actually do that. And finally, get everybody deploying. GitHub here are particularly good at this. If you're a new GitHub employee, you deploy the whole of GitHub on your first day. They build this culture where everybody deploys. Everybody knows how deployment works. Everybody knows that it's easy, that it's not particularly scary. And everybody's in a position where they can be invested in this. If you just have Bob on your team doing all the deployment, nobody else is really going to care about releasing, which is tragic because releasing is the only point where you do anything useful. But also it becomes very difficult for Bob to seriously actually be improving these processes. Nobody else really cares about deployment, and none of this stuff gets any better. Sharing this out across the team, having the whole team interested and invested in doing this well, will make your deployment better. There's a great quote from Jez Humble, the author of an excellent book on continuous delivery. This applies to a lot of this, but particularly deployment. When you're doing this stuff infrequently, it becomes much more difficult. Releases that are huge and big of all your code from the last 6 months are scary. There's more stuff that could break. So you put it out and it does break, so you're scared of it, so you do it less often, so they get even bigger, so you get more scared of it, and it gets worse and worse. And you have to break this loop. If you charge into it and chase frequency, if you try and deploy much more often, you end up doing much smaller deployments, which get much easier. You also get more feedback about how your release process works. When you make a bunch of improvements to how you release, when you add a bunch of automation, you get to immediately see the effect of that. And this lets you improve your release process further. This builds upon itself. Deploying every commit really helps with this. Deploying commits to production, obviously, is a scary place to be. There's still quite a lot of value, if you want to get this feedback, into just setting up new environments for developers that developers really care about, that you run your standard deployment processes against. And you find out really quickly if your deployment processes start breaking. You have to care about these environments, you have to be invested in them, but it lets you continually test this stuff, and it gives you a lot of quick feedback, and people get used to the idea that deployment is important. Even if you can't do this, deploying every night has quite a lot of benefits. Critically, nightly deploys absolutely should do the same thing as the previous deploy did. Right? Nothing has changed. So as soon as that fails, you've got an enormous red flag, which is very useful. And this also helps stop code bases kind of rotting. If you've got lots of code bases getting independently deployed, it can be easy for something to not get any attention paid to it, and for you to discover when you pick up a project, you can't deploy it anymore. The steps don't work. Somebody's changed the servers. If it's automated and it's happened every single night, you know that's not the case. So we've gone from releasing very rarely to instead chasing these very frequent, very small releases, removing the risk, making it easier, with lots of automation, measuring things particularly, so that you get these benefits and you get this quicker feedback from your customers. So just to wrap up, it's important to note a lot of these are cumulative. So particularly some of the releasing stuff we were talking about there. As your releasing process gets better, it gets easier to improve your releasing process. So it can get even better, and so on and so forth. It's very easy to undervalue the benefits of all of these kind of changes by just looking at the time improvement you're going to get from the single change, but they feed into themselves. They make further changes to your build tools easier. They improve the culture towards improving these tools, and it is much more likely that you are undervaluing these than you are overvaluing them. Again, I do want to emphasize, this is not architecture. Don't try and design the shiny, perfect thing that you're dreaming of. Focus on specific problems, specific smells and issues that you can see that are causing you pain. Try things that you can find to make that work. Chase down actual issues and things that are hurting your team, and measure the results. Try and experiment and see whether these actually help you. That's everything I've got for you today. Again, I'm Tim Perry, Pim Terry on Twitter, and I'll stick the slides up later so you can take a look through these. And I do work for Softwire, and we are recruiting and available for hire, as ever. Thank you very much.